Hello guys, welcome to my channel. So in this video I am going to discuss about the set theory concepts, set theory and algebra. So before that, I want to mention the point that since the syllabus related to GATE examination, GATE, UGC NET and KSET. So I'm going to discuss the computer science engineering related topics, computer science and engineering related subjects. Okay, related subjects, the theory concepts and MCQs, and we'll start with the subject set theory and algebra, then graph theory, and after that again like digital logic design, computer organization, architecture, software engineering and all. So we'll continue. Okay, so now we'll start with the basic concept, that is we'll start from the basics. So here the mathematics, that is the concept, some basic concepts. So a set is an unordered collection of the objects. Set is an unordered the collection of the objects. Okay. Okay, so set is an unordered collection of the objects known as elements or the members of the set. So a element A belongs to a set A can be written as, like for example, this A is an element that belongs to the set A, that we write it as this symbol. Okay, suppose if A is not belongs to element, this is A is an element, and if this element is not belong to the set, if A element is not belong to the set, that denotes it is not an element of the A set. So representation of the set, there are three common methods are the representation of the set, that is a statement form, a roster or table form method, and a set builder method. So these are the representation of the set. So in the roster method, okay, so for example here in this representation the elements are listed with a pair of bracket. In the roster form the elements are listed in a bracket, curly bracket. Okay, so here if n is a set of natural numbers less than the 5, if n is number, the n is a set, this is a set are represented in the curly brackets. So if this n is set, if it is n set or it is a set of natural numbers, suppose if natural numbers less than 5, then we represent 3, 4 less than 5. So this is a set. The set of all the ovals, okay, set of all the ovals are represented like E, I, O, U. Okay, so this is how we represent the set, that is the roster form. Set builder form, a set builder is a set is described by the property that its member must satisfy. Okay, means set builder is a set described by a property that its members must satisfy. Its member must satisfy. For example, here x is an even number divisible by the 6 and less than the 100. Okay, so here x is a natural number that is less than the 10. Means this property here, it must satisfy the condition. Okay, set builder form. Then equal sets. Two sets are said to be equal if both have the same element. For example, uh, in any order. Okay, it is not compulsory like 1 2 3 4. This is a set A, and there is one more set B, that is 3 2 1 4. This is set B. So if these two sets, means here the equal number of elements, A is also contain the 1 2 3 4, B also contain the 1 2 3 4. So here both the sets, the order is not matter. Okay, both are the equal sets. A and B both are the equal sets. Okay, both are the equal sets. Both are equal sets. Okay, then next, that is about the equal set. A set is a set A is said to be a subset of another set B. Means here A is a set. A set is said to be subset of another set B. Subset of another set B. So subset we represent like this: A subset of B, subset of the set B, if and only if every element of the A is also a part of the other set B. So that is denoted by this symbol. A is a subset of the set B. So here A subset of B, that denotes A is a subset of the B. A is a subset of B. Okay, so to prove A is a subset of B, we need to simplify, show that if X belongs to A, then X is also belongs to B. Okay, so to prove A is not a subset of B, we need to find out one element which is part of the set A but not belongs to the set B. So here this particular diagram that represents U denotes the universal set. Okay, it's a universal set. Okay, universal set. And above Venn diagram that shows A is a subset of B. A is a subset of B. A is a subset. Okay, A is a subset of the B. A is a subset of B. Okay, so the size of a set can be finite or infinite. The size of a set can be finite or infinite. The size of a set that can be finite or infinite. Size of set that can be finite or infinite. So finite set of natural numbers less than the 100. For example, here means it is a finite, and there are natural numbers that is less than 100. Okay, so infinite set is a set of real numbers. Size of the set S is also known as cardinality of the number. Okay, that is denoted by this way: cardinality number. Cardinality number is denoted as in this symbol. Okay, let's consider A is a set of odd positive integers less than the 10. Okay, so here they are given a is a odd numbers, set of odd numbers, that is less than 10, and cardinality of the set is 5. Okay, cardinality of the set is 5. Cardinality of a set is 5. Okay, so cardinality of the null set is 0. So the cardinal here, how many elements are there? 5 elements. A set contains how many elements? A set contains 5 elements. A set contains the 5 elements. Okay, so A that contain the 5 elements, so the cardinality of a set is 5. Okay, and cardinality of the null set is 0. Okay, so that is about the cardinality. Suppose here a equal to, suppose the even numbers 2, 4, 6, 8, 10, 12. How many elements are there? 6 elements. So the cardinality of this set is 6. That is depend upon the number of elements. Then comes the power sets. The power set is the set of all the possible subset of the set S. The power set is the set of all possible subset of the set S, denoted by the P of S, power set. The set of all possible subset. Okay, all possible subset of the possible subset of set S is denoted as power of set. So what is the power set of 0, 1, 2? What is the power set of 0, 1, 2? So here we need to write all the possible subsets, all possible. Suppose here 0, 1, 2, this is the power set. And what are the possible subsets? Possible subset is first, this is a null set, then 0, this is one possible subset, 1, then this is 2, that is one subset, then 0, 1, then 0, 2, then 1, 2, okay, then 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so total 8 possible. So the cardinality of the power set, okay, the cardinality of the power set is 2 raised to n. This is the formula. So if the set, suppose if this particular A set contains how many? 3 elements. So 2 raised to 3, that is 8. 8 is the cardinality of the power set. Means number of possible subsets. Okay. The cardinality of the power set. Power set means what? Number of possible sets. Number of possible sets. So number of possible sets is 8. So how you calculate? That is with the formula 2 raised to n. Okay, suppose if the set contains like 2, 3, 5, 7, if the set contains 4 elements, then power set, what are the possibility of the cardinality of the power set? 2 raised to 4, that is 16. Okay, then okay, I think this document contains only up to the basic concepts. Set operations. So in this I am going to discuss about the set operation. So these are all content that I have taken from the internet source. Okay, Geek for Geeks, that is a very best website for the interview preparation and all. Okay, so here the set operations. Set operation. So the union of the sets A and B is denoted by A union B. A is a set and B is a set. Okay, so union of set A and B is the set of distinct elements that belongs to set A and set B or both. Okay, so A union B means here this is equivalent to the A union B, the set of distinct elements that belongs to set A and set B or both. Okay, for example, here above here the A set contains 2 3 4, B set contains 3 4 5. Okay, so here the A union B, the distinct elements in the A and B. Okay, so here 2 3 4 and 5, so that is A union B. A union B. Okay, so union of set A and B denotes the A union B is the set of distinct elements that belongs to set A or set B or both Okay, so that is about the union. Okay, A union B. So next comes the intersection part. Intersection of the sets A and B, that is denoted by A intersection B. Okay, A intersection B is the set of elements that belongs to both A and B. Okay, it is a common elements of A and B. Common elements of A and B. Common elements of the A and B, that is A intersection B, right? Common elements of the A and B. We will see an example. So here this is a Venn diagram. Okay, so this part. Okay. Okay, already it is colored and already. So this is A and this is B. Okay, so A intersection B. The common elements from both A and B. So here A is 2 3 4 and B is 3 4 comma 5. So here you can see 2 3 and 4. Here 3 4 and 5. So 3 and 4 are common. So here A intersection B can be written as 3 comma 4. 3 comma 4. Okay, so that is A intersection B. Then disjoint. Two sets are said to be the disjoint if their intersection is empty sets, that is sets have no common elements. Okay, if their intersection is empty set, that is sets have no common elements. Sets have no common elements, so that is disjoint. Okay, that is a disjoints. Okay, so A union B, then A intersection B. Okay, disjoint means if there is no common element. Okay, here in the disjoint there is no common element. Is here this is A and this is B, so there is no common element. Okay, in A intersection B, it is a null set. There is no common element. Set difference. Now the set difference is the difference between the sets denoted by A minus B. Okay, the difference set is denoted by A minus B. So which is the set containing okay, A minus B means which is the set containing the elements that are in A but not in B. Okay, set containing the element that are in A but not in B, that is all elements of A except the element of B. Okay, here all the elements of A except B. So A minus B means what? It is set containing the elements that are in A but not in the B, all the elements of A. So here this is the A minus B operation, where all the elements of A are considered. All the elements of A are considered. All the elements of A except the elements of B, that is A minus B. Okay, so next, the complement operation. The complement of a set A is denoted as, suppose if A is a set, the complement is denoted as AC. Is the set of all the elements except the elements in A. Okay, set of all the elements except the elements in except the elements in A. Complement of the set A is we can write like universal minus A. Okay, except A, the elements, for example here it is a universal, so total universal, so in that there is a Okay, so except this okay, except this A all. Okay, except this A all. Okay, that is a complement of A. The set of all the elements except the elements in A, except the elements in A, that is complement operation. Okay, so about the Venn diagram, so here we can see the universal set. They are given 1 2 3 4 5 6 7 8 9 10, that is a universal set, and A is 2 4 6 8. Okay, this is a set, and okay, here the complement of A is means except this particular set. So 2 4 6 8. Okay, 2 4 6 8. So remaining, what are the elements? 1 comma 3 comma 5 comma 7 and 9 10, right? So this is the complement of A. So the what is the operation? Complement of A is union minus A. Okay, so addition and subtraction. Addition of the sets A and B is referred to as Minkowski addition. The addition of set A and B is referred to as Minkowski addition. Is the set in whose elements are the sum of each possible pair of elements from the two sets. Okay, so set subtraction that follows the same rule but with the subtraction operation on the elements. Okay, so there are some laws are there that we'll discuss. So after the set operation we'll go for power set and its power. So here power set and its property. Power set and its property. Okay. So we are just now we covered some basics and set operations and all. Power set. Okay. So cardinality of the power set. Power set means number of possible subsets. Okay. So here for a given set S, the power set is 2 raised to S, that represent the setup containing all possible subsets. Okay. So power of a set means the sets that containing all possible subsets 2 raised to S. Okay. 2 raised to S. For example, if A contain the elements like 1, 2, 3, 4. A contain the 4 elements. So 2 raised to 4 is equal to 16. 16 possible elements. Okay. So power set, that is 2 raised to S, represent the set containing all the possible subsets of the S. All the possible subsets of the S. Okay. So here if you can see, if S is a set with 1, 2, 3 elements and power set 2 raised to 3 means how much? 8. Okay, 2 raised to 3 means 8. 8 possible subsets are there. Possible power set. So the one is the empty set, then 1, 2, 3, then 1 comma 2 subset 2, 1 comma 3, 2 comma 3, and 1 2 3. So total 8. 8 possible subsets, right? The number of elements in the power set. Number of elements in the power set. Okay. For a given set S with for a given set. Okay. For a given set S with n elements, the number of elements in the power set is 2 raised to n, as each element has two possibilities, present or absent. The possibility subsets are 2 raised to 3. The possible subsets are 2 raised to 3, that is 8. Okay. So what is the formula? Possible subsets 2 raised to n. Okay. 2 raised to n possible subsets. Power set of a finite set is finite. Power set of a finite set is finite. Set S is an element of the power set of S, which can be written as set S is an element of S. Set S is an element of power set of S, which can be written as, means this set S, it is an element of the power set of S. because power set of S means, power set means what? Power set means all the possible sets. Power set means all the possible sets, all the possible sets. Okay, all possible sets. Empty set pi is an element of the power set of S which can be written as empty set. Okay, empty set pi is an element of power set S. Okay, so this empty set is a subset of the power set of S which can be written as empty set. It is power of power set part. Okay, so here some examples. The cardinality of the power set, the cardinality of the power set, that is 0 to 10. 0 to 10. So here there are how many elements are there? The power set of this 1 to 10 plus 0. 0 is also there, so total 11. Okay, so 2 raised to 11, so that is 1024 to 2048. Okay, 2048. 2048. Let us see the answer solution. Okay, here it is. The cardinality of the set, the cardinality of the set is the number of elements contained. For set S with n elements, for set S with n elements, it is 2 raised to n elements. Okay, so here the size is n is 11, so the power set, the size of the power set, the size of power set is 2 raised to 11. 2 raised to 11, that is 2048. Okay, the size of the power set, there are 11. Okay, n is equal to 11, there are n elements are there, so 2 raised to 11 means it is 2048. Okay, cardinality of the power set. Okay, so next, for a set A, for a set A, for a set A, the power set of A is denoted by, for a set A, okay, for a set A, the power set of A is denoted by 2 raised to A. Okay, if A it contains, A contains a set, and that set contains, okay, A is a one set, that is 5, comma, it contains the subsets 6 and 7. Which of the following options are true? Which of the following options are true? Like here, what are the options they are given? Pi belongs to 2. A is a subset. Okay, A is a set. Here the power set of A, power set of A is denoted by 2 raised to A. So A is set, they are given. A set has these elements. Okay, therefore the power set of A is, we can write it as 2 raised to, yes, means what are the possible, okay, possible subsets. Possible subsets are, okay, one is empty set, then 5, okay, 5, then 6, 7, then 5 and 6, 5 and 7, then 6, 7, 5, 6, 7, okay, 8. So total it is 8. So what the statement 1 says, statement 1 is true, as we can see empty is an element of the 2 raised to S, means empty. So here this empty, that belongs to 2 raised to a. Okay, set 2 raised to a. A is a set and the number of possible sets are 2 raised to a. A contains about 3 elements, 2 raised to 3. Okay, so pi is belong to 2 raised to, that is 2a. Then second is, okay, this belong to and it is subset. Statement 2 is also true as it is an empty set. Then statement 3 is true as 5 comma 6 also belongs to, and 4 is not true. Here the option, it is not visible clearly, as 5 6 is an element of the 2 raised, not a subset. 5 comma 6 is an element, okay, it is not a subset. Yes, because here in this case the 5 comma 6, okay, so here this is a like 5 comma 6. Okay, so these are the elements, mean this belongs to the set. Okay, this is belongs to the power set. Okay, not belongs to okay, yeah, this is belongs to, but it is not a subset. Subset are what are the subsets? 5 6 and 7. So 5 comma 6 is not a subset. Okay, then let's p of s, the power set, denote the power set of s, which of the following is always true. Okay, p of is a power set of s, so power set of s. So let us assume that here one set 1 comma 2, what are the possible is 4, that is 2 raised to 2. There are 4 possible subsets, 4 possible subsets. So option is false, as the power set has 2 raised to 4 elements, and with respect to this power set of here p of ps, it is suppose here now power set is like 4, then p of ps is 2 raised to 4, that is 16. Okay, 16, so that are not equivalent. The option B is true, as intersection of S and P of S is empty set. So here the power set, okay, there are in the case, suppose if we consider 2 elements, then it is a 4. Okay, then the intersection with power of P of PS, it is empty, means there is no common. Okay, there is no common element. Power set is empty. Okay, so it is true, the intersection of yes and it is empty set. Thus option 3 is false, the intersection of yes and it is the empty set. And D is false, as S is an element of the power set. Okay. Okay. So next we'll discuss some programs, some problem statement. Okay, we'll see whether it is covered or same thing. Okay, these are some gate questions. For set A, power set of A is denoted by 2 raised to A. Okay, it is already gone through. That A is 5, 6, 7. Which of the following options are true? This empty set belongs to A, 2 raised to A, power set, true. This is also true. Okay, this is also true, means this belongs to and this is subset. Okay, empty set is a subset of 2 raised to A. Then 5 comma 6, these elements belong to 2 raised to, this is also true, but here it is false because this is not a subset. Here there is no subset, like 6 and 7 are subsets. 6 is a subset, 7 is a subset, but 5 comma 6, it is not a subset. It is not a subset, right? It is not a subset. So 1, 2, 3 are right. Okay. I think same. It is same. Okay. As these are the different sets, possible subsets. 2 raised to 3 means 8 possible subsets. 8 possible subsets. Okay, guys, it is about all the basics that we covered. So in the next class, again I will cover some of the basic topics from the set algebra, this set theory and algebra and all.